Hey, good morning everyone, it's Tractorman 44 here. Hey, we work on a few different things, on occasion. And my son called me the other day and he had bought him a brand new to him 2005 LTZ 400 Suzuki four-wheeler. That's a pretty cool bike. He bought it from a young fella, over the state line, which is no big deal, The boy told him that it had no spark. That's the only thing wrong with it, had no spark. Well, no spark can mean all kinds of things, from a bad spark plug to to corrosion on a battery terminal or something like that. There's any number of reasons it can cause to have no spark. My son's been around me obviously since he was a little boy, and he knows some of the trouble I get into whenever I come up with a good deal. You know what I mean? And this was a good deal, even with the troubles that he's got, or he's in the process of repairing. It is a good deal, but he's familiar with some of the things that I brought home, thinking it was a good deal, and turning out that it was a little more difficult. So we got into this thing. We got to digging around. He pulled all the plastics off and everything. We started troubleshooting the electric. We've got 15 splices that we found so far, and we've got 9 cut wires that are just cut off and go nowhere, as you can just see right here hanging around. Where do you start, you might ask? As with anything in troubleshooting, you start with the basics and what you understand and what you know. Battery has voltage. You start off with that known battery voltage, and then you work through the sequence of switches and things. We went through the whole process. Of course, there was no spark. The boy was right about that. There was no spark. We found out some issues with corrosion on the kill switch. We found some issues with the way the actual on-off switch, or ignition switch was wired. We corrected that. Still no spark. We found no ground, in a particular circuit, because this guy switches some of the stuff, switches the ground in order to make it function. We got that all fixed, no problem, but still no spark. Then we got down to the ECM, or electronic control module, or Cdi box is what they call them on these guys right here. And the Cdi box the wiring harness doesn't necessarily match the wiring diagram that we have in that manual, so we had to do a little bit of interpolation and try to figure out what was going on. Well, whenever we decided that there was a wire that was not correct in the wiring harness compared to the diagram, we decided to bare back one of the wires on the CDI that looked like completed the circuit the way it needed to be to make it function, and we just tried it gently, and guess what? We have spark and we have rotation of starter motor, two things that he never had before. I guess the point of the video is to let you know that there are plenty of bargains that you can actually come into if you're willing to put a little effort into troubleshooting and making repairs. And most of this stuff is really not beyond the average person, as long as you understand or have a basic understanding of electricity, electron flow, what happens in electrical circuits. And you have to be able to kind of use a little bit of logic and think of what the people that designed the circuit that you're working on really intended on it doing, in order for you to take the chances that you sometimes have to take to get electric to go where it needs to go to make this thing, to make it function. So at any rate, like I said, this is not a how-to video. It's just a kind of putting a bug in your ear video about the things that you can run into. Don't be afraid to jump into them if you've got the ability to kind of do a little logical troubleshooting. My channel is primarily tractors and working around the shop and things like that. But even on tractors and equipment, don't be afraid, as long as you understand, the basics of electricity, to jump in and do some repair. Even mechanical, it's not that big a deal. After all the troubleshooting was done, he made the repairs on the workbench, and now that the repairs are all made, we're dry fitting the harness to make sure that any of the lengths of wire aren't too short or anything like that, so we can adapt it before it goes together permanently. And then once he becomes sure that everything's going to fit where it needs to, this will all get a wire loom around it from front to back. Everything across it will be encompassed in a wire loom and securely attached to the frame in a position where it's not going to rub on the seat or any other moving parts or whatever, as the suspension or the travel of the suspension causes the frame to move up and down. And also, in the event that any of the rear lighting and stuff, he decides to put any of the rear lighting on, he's extending the wiring harness back to pick up, the rear light for the brake light and the tail light and things like that. This is primarily going to be an off-road machine, but if he decides to sell it, it'd be kind of nice to be able to have all the accessories on it that operate and function like it should. Now, once you get into one of these bikes this far, it's silly not to go ahead and do a complete, thorough service of the carburetor. And in this particular case, it's kind of a good thing that we did, because we found a diaphragm that was actually folded over. probably not doing what it's supposed to do, so he's got to get that on order. And I think there might even be a missing O-ring or two in the carburetor body that seals the two sections together. Because I'd like to make sure the carburetor is perfectly dry, and then one passage at a time apply just a small amount of carburetor cleaner in that passage, and then blow through it and make sure that where that passage comes out the other side, you can see the moisture from the carburetor cleaner. Do that on every individual passage, and you'll make sure that you've got a clean carburetor ready to reassemble and put back in service. Well, after several months of waiting on parts and many other projects to come and gone in the meantime in the shop, we're finally back on this LTZ 400 Suzuki. This actual project, when we started the work on this Suzuki, was the project in my mind that caused me to go ahead and make these accessories, so to speak, for the two-post car lift to allow us a little more ease to in working around it. The lawnmowers work fine; there's not that big of a deal. But this one here, we decided to literally lift it up and carry it and put it crossways so that we have access to either side of the engine without having stepping over anything. So that's not the easiest thing in the world, but it's a lot better than working on your knees. We'll go ahead and change this thing's elevation, go to work on it, and I think it's going to work out just fine for us. What we had is we opted to go ahead and have a little machine work done to the head, and so he's going ahead and installing that right now. We're getting ready to drop the cams in and all that. Got a new set of valves and everything, the whole bit. Now, if you do any amount of head work at all on these 4 strokes here, you're going to find out that you're going to have to do some valve adjustments. I don't know if you worked on any of the older engines or whatever, but these here, and I don't know when they stopped or even if they have stopped it, but these here adjust by means of what they call a bucket and a shim. Essentially, there's an inverted bucket that becomes your lifter that sets down inside the machined area where the valve spring is going to rest once everything is installed, and the valve spring will actually insert right into that bucket, and then the valve stem, where it's retained, where the valve keepers go in, is a recessed area in it where a shim actually goes in. Those shims are available from a certain length in 2/1000ths of an inch increments up to a maximum length. So what you have to do to adjust your valves is you have to rotate your camshaft around till you've got it off of the valves, measure that amount that is worn between the camshaft and the valve, or the lifter, in this case the bucket, and then you have to see what the specification calls for, and then see how much wear by comparing the two, and then order a shim. Once you take it apart and see what the size shim is in it, you have to order a shim that length plus the length that you need to make up the distance for the wear. Don't know if that makes any sense, but that's the way it works. Here's a disassembled valve spring right here. Now, of course, this would normally be inserted through the head, and then the valve spring itself will be depressed, and then the keepers will drop down inside here, and then that's what will hold the valve in place. If you take a look, there's your recessed area I was talking about. That's where the shim actually goes down in, and the shim actually rests on the stem of the valve. So whenever the camshaft comes around, pushes on the bucket or the lifter, then that's what depresses the valve, which opens the intake or exhaust, whichever one it is. And so that's the thing that you have to be concerned about. So here will be your shim dropping right into that opening right there. And you can see, like right now, well, right now it's not assembled, so I don't have anything holding it in place. But if you take a look right here, you can see that's just up a little bit. Okay, well, if you add to it, of course, it's going to be higher, and the higher it gets by adding more and more to it, the farther it's going to be depressed with each rotation. So at any rate, that goes on there like that, and then the bucket, which is the lifter, just sits right down over the top, right into the insert, and then that shim touches the inside of the bucket, rests on the stem right here, and the camshaft goes around and around and does its business by pushing the valve in the direction it needs to be pushed, in the height and the duration that it needs to be pushed, and the length of time that it needs to be open to get your fuel into if it's an intake, or to get your expended fuel out of if it's the exhaust. Does that make sense? But that's a Cliff Notes version of the way a shim and bucket valve adjustment setup is on these motorcycle engines. This one here is not that old. This is an '04. This is one of the newer ones I've worked on. But the old ones, you know, yeah, you kind of get used to this silly stuff. Now, in this particular engine, whenever you get ready to install your camshaft, you have to make sure everything is properly timed, of course. So we have to set the crankshaft or the piston at top dead center, and then we have to align the marks correctly on the exhaust cam gear and the intake cam gear. And that happens to be a set of marks or on the gears that will actually be horizontal with the top of the cylinder head. At the same time, that number 3 is pointing straight up, number 2 is pointing straight up, and there's 15 cam chain pins in between the 3 and the 2 mark. If you have all those correct, you have these all correct with the crank at tops or the piston at top dead center, timing is going to be correct.
As you can tell, the LTZ is back in running condition. Yeah, he likes his four-wheeler, there's no doubt about it. Well, now except for just a little bit of adjusting, a little bit of tuning, and getting the plastic and stuff back on, tighten up the wiring harness, this thing's ready to go out and have some fun. So it looks like it's going to be a halfway decent runner. But you never what you're going to get. You never know what you're going to get when you buy something that's had some damage to it. This one had some surprises, boy. You know what? This is Tractor Man 44 and his son, and we are out of here.